Okay, good afternoon, everyone, and welcome to this session. This is the fifth session that we are conducting with the juniors, and I hope that you have been you have enjoyed the previous sessions and have learned quite a few things. Today we are going to um, deal with problems involving numbers, factorization, and things like that. Um, and Natural numbers, the counting numbers, are the first things that you are ever exposed to in mathematics. You learn how to count. But yet, the mathematics around counting numbers can be quite deep and quite advanced. So we are going to see some problems where you have ordinary arithmetic involved, but it still can pose quite a challenge to a number of mathematics learners. There have been some great discoveries over the years regarding numbers, and hopefully we can unpack some of those. But today we're going to start with some elementary examples, like the first one, which is on the screen. I trust that all of you can see it. Khotso, is the screen visible?
Yes, Prof. I can see.
Okay, thank you very much. Okay, the first question is, how many factors does the number 600 have if 1 and 600 are included? I suspect that I had done something like this before, but let's just quickly look at this problem again. Actually, if you have a, let's take a simple example. Suppose I ask you, how many factors does they say the number 24 have? Right. I can write down the factors. It's 1 and 24. You're allowed to include 1 and the full number. Then you have 2. I like to write these factors down together in pairs. 2, 12, 3, 8, 4, 6. And beyond that, the next factor is 6. But 6 is already there, so we don't have to go any further. So there are 8. There are 8 factors. Right. Now, another way of writing this thing down like this is, instead you can write down 24 and factorize it as products of prime numbers. It's 8 times 3, and that's 2 cubed times 3. Now here you got all the numbers. The bases are all prime numbers. Every number can be factorized in terms like this, in powers of primes, right? As a product of powers of primes. Every number. So this is one of the more beautiful things about natural numbers. The prime numbers can be used to create any given number. That is why prime numbers are so important. Okay, now if you write it like this, then you can see what the factors are going to be. You can just take the first one, 2 cubed, and write down all the factors of 2 cubed. It's 1, 2, 2 squared, 2 cubed. And the factors of a prime cubed are just the powers of that prime, right? Because the 2 has got no other factors. So those give you 4 factors. That's 1, 2, 4, and 8. That's taken care of here. And then the other factors are 3 times 1. Now I can multiply every one of them by 3. 2 times 3, 2 squared times 3, and 2 cubed times 3. Now this is what you have: 3, 6, 12, and 24. When you work that out. And that takes care of 3, 6, 12, and 24. And you can see now you've got all 8 factors. But in factorizing it like this, it's very systematic. You look at all the factors of 8, and there are 4 factors the reason why there are 4 factors is 8 is 2 cubed, right? And the factors are, they're not 3 factors. 2 squared, 2 cubed are not the only factors, but 1 is also a factor. So it's got 3 plus 1 factors. The powers starting from 1, 2, 3, and then the 1 itself. So 8 has got 3 plus 1 factors. And the same way with 3 has got only 2 factors, 1 and 3. Okay? So that is 1 plus 1. And then if you multiply these two together, 4 times 2, you get bingo, you get 8. So that is what we did. We found 4 factors, and for each of these 4 factors, we found that there is one other factor when you multiply it by 3. All right. And that gives you a general rule. The general rule being that when you are factorizing a number like 600, right? I'll tell you how to factorize 600 very quickly. This is what I do. I just put 6 times 100. And then I factorize 6. And then I factorize 100. Now these are primes, so you can't factorize them any further. But 10 is not a prime. I can still factorize it. Right? And now you got all prime numbers. And you can see that there are 3 2's there, so it's 2 cubed. And then you got a 3, only 1 3, and you got 2 5s, so that's 5 squared. See? So this is the factorization of 600 as a product of prime powers. These are all prime powers, 2, 3, 5, and they are powers of primes. Right. So once you do that, then you can use this thing here to work out how many factors. You take 3 and you add 1 to it. Right? And we multiplied all these things. So it's 3 plus 1 times. Now the power here is just 1. So it's 1 plus 1, as we saw here. Right? And 5 squared will be 2 plus 1. So you multiply all these, and that will give you the total number of factors. This is 4 times 2, which is 8 times 3, which is 24. So that tells you that 600 has got 24 factors. So without actually writing them down, just by simply factorizing it as the powers of prime numbers, you can write down the number of factors immediately. So if you want to write down a general rule, number of factors of, if you write the factors down as 2 to the power of, say, a1 times 3 to the power of a2 times the next prime is 5 to the power of a3. Every number can be written as a product of prime numbers. Yeah, I'm including the a's to be 0. You see, sometimes, like for instance, in 600, I had, okay, that's a bad example, but you had 2 to, what did we have? 2 cubed times 3 times 5 squared. I could put 7 to the 0, 11 to the 0, and so on. Because these are all ones. So I can write every number as a product of all prime numbers. If you put all the prime numbers as bases, and if you allow 0 at the top, but we don't normally allow the 0. Because when you increase 0 by 1, you get 1. And when you multiply all these things, you're simply multiplying by 1, which doesn't make any difference to the answer. So we leave these factors out. But if you write this thing down, the number of factors of this is a1 plus 1. See, the powers are a1, or the exponents, or the indices. We call them powers or exponents or indices, times a2 plus 1, times a3 plus 1, and so on. Keep multiplying all these, and that gives you the number of factors of any number. All right, I hope that you understand that. We can now go on to the next problem. The next problem says, so we're continuing the same line. Find all numbers less than 30 that have exactly 4 factors. All right. So now you know the number of factors. So you know that the number of factors is, as we saw, so if you take a number less than 30, say, oops, sorry. If you take a number less than 30, say let n be less than 30, and suppose I factorize n as 2 to the power of a1, 3 to the power of a2, and so on, then we have, it's got exactly 4 factors, which means that 4 is equal to, and we've got the formula for the number of factors, is a1 plus 1, a2 plus 1, and so on. So we don't know what these are, but we know that n is less than 30. But 4 has got very few factors, right? You can factorize 4 in only 2 ways. It's either 1 times 4 or 2 times 2, right? So which means that these numbers here are either 1 or they are 4. Now, let's take this first one. If you have these numbers are, if any one of these is 1, a1 plus 1 equals 1, that means a1 is 0, which means that the power of 2 is 0 and it shouldn't be there. We don't include that in the factorization. We don't include 1 as in the prime factorization. All right, so in this case here, we can ignore 1, but this thing here is important because now you have that the power is, in the case of 1 times 4, the power is, if you want, you can say, yeah, it's 3 plus 1. So the power is 3, okay? Or the prime power. So here you have only one prime base, right? So what you have here is, which are the prime numbers whose power is 3? So you have 2 cubed, you have 3 cubed, and you have 5 cubed. So the number of factors of 2 cubed is 3 plus 1, which is 4, right? Because these are prime bases. So these are allowed, but we want them to be less than 30. And 5 cubed is too much. There's 125 there. So here, these numbers give you 8 and 27. I've got 4 factors. All right. Now, we finished with the first one. Let's take the 2 times 2 one. 2 times 2 means that the powers are now 1, right? The indices are 1. 1 plus 1 gives you 2. So you have a number like 2 to the 1 times 3 to the 1 times 5 to the 1 times 7 to the 1 and so on. But basically, there are only two factors. So you can't have a thing like this now. It has to be, say, 2 times 3. Now 2 times 3 has got 4 factors because this is 1 plus 1 times 1 plus 1. Right. So in other words, this gives you a product of two prime numbers. any product of two prime numbers has four factors. Four factors, right? So how you can start with 2 times 3, but it can only go up to 30. So it's 2 times 3. It can only go up to 2 to the power of 2 times 15. So it's 2 times 3, 2 times 5. It must be prime numbers. 2 times 7, 2 times 11, 2 times 13. That gives you 26. And you can't go beyond that because the next one is 2 times 17, which is too much. But now you can start with 3. 3 times 5. 3 times, it must be two distinct prime numbers. 3 times 7, that gives you 21. And 3 times 11 is too much. So you stop there. And then when you come to 5, you can only have 5 times 7, and that's too much. So these are the only ones. 1, 2, 3, 4, 5, 6, 7. So you can write down all these numbers. And so the answer is, as you can see, you include your 8 and the 27. That was the case where you got 1 times 4. And then the case 2 times 2 gives you a product of two prime numbers. And if you work those things out, you get 6, 10, and so on. All right, so you can write down all the possible numbers less than 30, which have got exactly 4 factors. Okay, so I went through that rather briskly, but think about it. And if you get stuck, you can always go back to the recording. And hopefully you have good access to the recording. All right, let's get to the next problem. The next problem is okay, now you have this thing in the equation AB times CD equals DDD. All right, so you've got a product of two numbers. Evidently, these are, they say, they represent a different digit. Each of the letters represent a different digit. A digit is a number like 0, 1, 2, up to 9. Those are the digits. So in other words, this is a two-digit number, right? And A stands for a digit and B stands for a digit. But if B is repeated, it means the same digit occurs here. And here you've got all the same digit occurs right through in this three-digit number. All right, now the question is now to calculate, to find what A, B, C, and D are. And once you do that, then you can calculate the sum of A, B, C, and D. All right, let's analyze this thing here. You see, this D is an interesting number because all the letters are exactly the same. Now, if you take, for instance, if you take 666, right, straight away you can see this is 6 multiplied by 111. Okay? And if you do this for 888, 888, that is 8 times 111. So DDD is actually, it is 3, a D multiplied by 111. Okay, but now you've got this three-digit number is a product of two-digit numbers. Now this is not a two-digit number, 111, but it can be factorized because the sum of those numbers is 3. So 3 is a factor of this. 3 goes into 111 37 times. All right, so your number is actually D times 3 times 37. So now this is equal to, or only a product of two numbers. This is AB times CB. This is what is given. The DDD is AB times CB. Now, immediately you got a two-digit number, and this one here will be another two-digit number because, well, sometimes D is a single digit, but 3 times D, sometimes like 3 times 4, 3 times 5 and so on. They are 2-digit numbers, but the highest value it can have is 27. So this is uh, so 37 is one of these. So therefore, AB or CB is 37, which is very nice, because then we know that because B occurs twice, so B must be 7, right? Because you got both of them end in B, and 37 ends in 7. So B must be 7. Now, once you got B is 7, then you've got now you got one of these factors is 37. Now the other one, so D times 3 ends in 7, because the other factor ends in 7 also, ends in B. And the only way D times 3 can end in 7 is if you try all the numbers, only 9 times 3 ends in 7. 9 times 3 is 27. All right, so this is where we are. All the none of the other numbers multiples of 3 end in 7. Okay, so you got B and D, which helps a great deal, because D is D. So you got, therefore, you got what the product is. D is 9, and here you got 37 is one of them. And as we saw, the other factor is 3 times D, which is 27. So now you got the complete factorization of this thing, and you've got all the symbols. So the symbols are 2 plus 7 plus 3 plus 9. These are the 4 numbers which are occurring here, 2, 3, 7, and 9. And you want those 4 numbers, you want to know what the sum is, so that gives you 21. All right, it's a very nice problem, very logical, and the argument is that you've got two-digit numbers, which ends with product is a 3-digit number. That 3-digit number you can factorize very easily, and then you see what are the 2-digit factors of this thing here, and you see the 37 is one of them. So immediately the logic sets in, and you can decide that B is 7, and then a little bit of thought will tell you what D is, and you can go on and proceed to solve the problem. Okay, so that's a nice problem on simple logic. So as you can see now, these are all examples of natural numbers, right? We don't have any fractions or irrational numbers or anything like that. Yeah, we've been looking at factorization, which you learned in primary school, and so on. So these are quite working with only natural numbers. Okay, we can go on to question 4. Question 4, it gives you an 8-digit number, 1287A45B. So 2 of them are unknown. A and B are unknown. Those are not given. All right, so what else do we know about this? A and B are not 0, okay? And they are digits, right? So A can be 1, 2, all the way up to 9, and B also 1, 2, all the way up to 9. It's not 0 is a digit, huh? Like 407, 0 is a digit. But in this case, A and B are not 0. Okay, so that at least now that limits the A and B to only 18 numbers. Okay, we'll have to try to find out exactly what they are. Now the number is divisible by 18. Okay, so 18 is a factor of this number. Of this big number. Now 18 is 2 times 9. 18 is 2 times 9. So 2 times 9 is a factor. And therefore 2 is a factor. 2 is a factor. And so is 9. If 2 times 9 is a factor, then 2 is a factor and 9 is a factor. Each of them would be a factor. All right. Now that gives you a good start, because if 2 is a factor, that means the number is even. The number is even. Now this is the number we are talking about. 1287A45B. So this number is even, so which means that the last digit is even. That everybody knows. For a number to be even, the last digit is even. So therefore B is even. And B is coming from 1, 2 up to 9. And you're looking at an even number from there. So B is equal to 2 or 4 or 6 or 8. You see, you brought it down from 9 possibilities, brought it down to only 4 possibilities. All right, so that takes care of B. Now let's see, what else do they say? Oh, okay, what we are given now is that 9 is a factor. Now 9, divisibility by 9, I think you all know that, what the rule for divisibility by 9 is. So by the way, you have to know the rules, divisibility rules. Maybe I should go over that quickly. The rules for divisibility. Now, what does that mean? That you can actually, I'm just going to digress a little bit. It's going to take a bit of my time, but let's hope it doesn't take too much of time. So I'm going to go through this thing quickly, because if you are entering the second or the third round in the Olympiad, by this time we assume that you know all these basic things. The rule for divisibility by 2, just the last digit is even, as we saw. 3, sum of digits is divisible by 3, or is a multiple of 3. So if you want to check to see whether a number is divisible by 3, the sum of the digits. I used this earlier on when I said 111 is a multiple of 3, because the sum of the digits there is 3. So therefore 111 is 3 times something, right? Divisibility by 4, you look at the last 2 digits and you see whether the last 2 digits is divisible by 4. When I say last 2 digits, I mean the 2-digit number at the end is divisible by 4. Like for instance, 493684812. This massive number. If the last 2 digits is 12, right? You take a 2-digit number, and 4 goes exactly into that. So therefore, 4 goes into this big number. All you have to do is to just check to see if 4 is a factor of the last 2 digits. 5, you know, 5 ends in 0 or 5. Multiples of 5 end in 0 or 5. 6, you have to check 2 and 3. You have to see whether it's even, and also whether the sum of the digits is a multiple of 3. So you have to take 2 checks, and that will tell you whether it's 6. 7, we don't know. So 7, there are rules, but that's not very well known. And then you got 8 also. 8 is the last 3. So in 2 is the last digit, in 4 is the last 2, and 8 is last 3, because these are 2 squared and 2 cubed. So if you take this number here, 812, the last 3 is 812. When you try to divide it by 8, you see it's not a multiple. It's a multiple of 4, But 8 does not go exactly into this. Very quickly, you can check it out. So therefore, this is not a multiple of 8, right? But if you had 816, for example, that is 8 goes exactly into that, then it will be a multiple of 8. And 9 is the sum of the digits, must be divisible by 9. Just as in 3, right? 3 and 9, they have the same kind of pattern. 3, the sum is divisible by 3. 9, the sum is divisible by 9. So here it means now that this thing here is a multiple of 9, which means that the sum of all these digits, if you add all the digits, let's just do it quickly. 1, 2, 8, 7, 4, 5, you get 27. Those are the divisible digits. And the other two are 27 plus A plus B, right, is a multiple of 9. I use the words divisible and multiple interchangeably. You say that 9 is a multiple of 3, or 9 is divisible by 3. It means the same thing, right? So this is a multiple of 9. Now 27 is already a multiple of 9, right? So when you're adding A plus B and that is a multiple of 9, it means that A plus B is a multiple of 9. So A plus B is a multiple of 9. Now A and B are digits, right? And the only multiples of the first digits, multiples of 9 are 9 and 18. You can get 9 and 18 from what we saw earlier on, but you can't get 27, right? So the highest possible A plus B is 18. And there's only one way you can get 18, where A and B are both 9, right? So you have that A equals B equals 9. And that has to be eliminated because we saw that B is even, right? B cannot be 9. All right, so that is off. So therefore, you will have that this is for 18. Okay. Now let me take all these out. So we are at this place here where we know that the number is divisible by 9, and the sum is not 18, because we saw that only in one case you can get 18, where both A and B are both 9, and that's not allowed because then B has to be 9, which is not true. So therefore, A plus B is not 18. There's only one possibility is A plus B equals 9. All right. So this is where we are. We got B is equal to 2468, and A plus B is 9. So the question is now, what is the maximum possible difference between A and B? All right, now that's an interesting question. You've got the two numbers add up to 9, and the difference between those numbers must be as large as possible, right? Okay, we know the values for B, so you have that AB. I'm putting it as a pair like that because I'm going to see what A is. If B is 2, then A is 7 because A plus B is 9. Or if B is 4, then A is 5 because A plus B is 9. Or you have, if B is 6, then you have 3, because 6 plus 3 is 9. Or you have 2, 4, 6, 8, and you have 1. 8 plus 1 is 9. So the question is, what is the maximum possible difference? The difference here between A and B, you can see, is 7 minus 2, which is 5. And there's 1 here, and there's 3 here, and this is 7. So the maximum possible difference is where A is 1 and B is 8, and the difference there is 7. So the answer is the largest possible difference you can get is 7. So you can see, there are all kinds of interesting questions that one can ask with numbers like this. This problem here is testing divisibility and using the divisibility to logically decide on the answer to a question. But you have to think of it, go slowly. As you saw, I took A and B not equal to 0. I stopped right there and I wrote down what information I can get there. I said divisible by 18, so I said it's divisible by 2, and then I went here, right? And then I took the divisible by 9 and then analyzed that. That was a little bit more tricky. And having found, we found that there A plus B will have to be equal to 9. And that is a nice simple equation. And you can see that 4 different values of B will give you 4 different pairs. And amongst those pairs, you're looking for the maximum possible difference. So this is a very logical way of solving the problem. It's not a straightforward thing where you just make some calculations. We are now in problem solving, you see. This is a nice thing about Olympiad mathematics, where you have to think and figure out what the question is and try to um, get to the answer by understanding the question and going through it piecemeal. Just one moment, please. Okay, move on to the next question. All right, so what we're going to do now is, the next question is, the decimal form of 3 divided by 7 is a recurring decimal. Recurring means the same thing starts repeating. So here you've got, when you write down 3 over 7, right, it's actually, if you want to calculate what the decimal expansion is, you take 3 and divide it by 7. I like putting it like this. And 3 is the same as any number of zeros. You're dividing by 7, and you have 7 goes into 3 0 times. Now you can take 30. 7 goes into 34 times. Remainder 2. 4 sevens are 28. 7 goes into 20 2 times. 14. Remainder 6. And there you have it. Right? So this is what happened here. You got 8, 5, 7, 1. And then you see you got 4, 2, 8, 5, 7, 1. So these things, these 6 numbers, they keep repeating. It goes on endlessly. It doesn't stop. This is an example of a recurring decimal, infinite recurring decimal, because it doesn't stop. See, unlike if I took a half, you all know that a half is 0,5, but I hope you know why, because you're dividing 1 by 2, and 2 goes into 1 0 times, 2 goes into 10 5 times. And after that, you got all 0. Therefore, half is equal to 0,5, right? Maybe you didn't know that, why it is so. Or you know a quarter is 0,25. 4 goes into 1 0 times, 4 goes into 10 2 times, 2 4 is 8, 4 goes into 20 5 times, exactly. And after that is all zeros. So if you got zeros at the end, you just eliminate it. So therefore, a quarter is 0,25. See? So these are terminating decimals. In other words, they end. Right? But this one here is non-terminating. Now, they say, what is the digit in the 2025th place? Two 2025th digit. We know that this thing keeps repeating like this. So how do we find out what the 2025th digit is? Well, let's repeat as many as possible. You see, you got the 6 in this group, the 6 in this group, and each group has got 6 in it. So if you want to go to 2025, those numbers somewhere you got 8, 5, 7, I'm sorry, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, and so on like that. And there are lots of other numbers in between. Now, I'd like to see how many 6s there are into, there's one of these numbers is going to be, we don't know which one, it's going to be at the 2025th place. We don't know which one. Could be any one of these. But if you keep taking groups of 6, then the question is, how many groups of 6 are there in 2025? So that's an interesting question, because you want to see how many groups are there. You want to get as close to 2025 as possible, right? So the groups, you say, really, how many 6s? How many 6s are there in 2025? Now, that is a simple division sum, because you simply divide 2025 by 6. 6 goes into 23 times. 3 6s are 18. Remainder 2. 6 goes into 22 again 3 times. 3 6s are 18. Remainder 4. And 6 goes into 45 7 times. Remainder 3. So it means that when you come to the 2025th position, we don't know what this is, but the remainder is 3. So the 2022, the 2022, right? The multiples of 6 end here, right? But the 6th number is 1. 1, 2, 3, 4, 5, 6. The 12th number is 1, right? The last number in this group is 1. So the last number in 2022, this number is 1. Because this is a multiple of 6. At all the multiples of 6, it's 1. So the 2022nd number is 1. So now you'll know what the next one will be. 2023 will be 4. 2024, 142, and 2025 will be 8. 1428. Right? So that tells you, that gives you the answer to the problem. The main question is now, you got groups of 6 all repeating themselves. So you can answer the question if you know how many groups of 6 there are, and there are 337 groups of 6, and the last group of 6, which is in the 2022nd place. And at that place, there is a 1, because at the 6th and the 12th and so on, there is 1. And once you do that, then you can work out what the 2025th number is. Okay. All right, so that takes care of question 5. Okay, question 6. The 24-digit integer. Oh, you got a whole lot of ones here. Hope there are 24 ones. It is divisible by 1111. How many zeros are there in the quotient. Now, I've actually made the division. Now, it's divisible by 1111. It's 24 digits. And you can see the groups of 111, this number here, they keep repeating. There's a 111 here, and the 4 ones, 4 ones. And if there are 26 numbers, we don't even have to count them. It means that there are 6 groups of 4. That's what I've done here. 1, 2, 3, 4, 5, 6. I've separated the 24 into 6 groups of 4, and I'm going to divide this. I'm going to divide this number by 1111. 1111 in other words. So when I divide this by 1111, I'm actually writing down the answer here. Because 1111, it goes into these 4 numbers one time. Right? But now when you come to the next one, right, you have to put a 0 under this, a 0 under this, because 1011 does not go into 1. It goes into it 0 times, and the remainder is 1. You can put 11 here. 1011 goes into 11 0 times again. The remainder is 111. Yeah, until you come to this last one, the remainder is 11 goes into this one time into this entire thing. So it doesn't go into 1, it doesn't go into 11, it doesn't go into 111, but it goes into this one time. So you can do the same thing with each as you go on, starting from 1 here, and then you got 0001, 0001, 0001 like this. And the question is, how many zeros are there in the quotient? The quotient is just when you divide this number by 111, you get a quotient. This number is a quotient, and you can count the number of zeros easily. There are 5 groups of zeros, and it's 5 times 3, because each group has got 3 zeros in it, which makes it 15. So the answer is that there are 15 zeros in this. See, again, it's a question of division. You notice there's a lot of questions involving division. And we've done a few so far, and I hope you got the hang of it. When you're dividing, there's a way to divide, right? You just keep dividing and taking remainders and carrying them over to the next one. That's the way to divide until you come to the last one. You can write the remainder. Yeah, the last one here, 1111, this number here goes exactly into this, and there are no remainder because it goes exactly into this. So this becomes a quotient. Okay. All right, so the answer to that question is 15 zeros. Let's get on to the next question. Now, when 2025 is divided by n, a remainder of 16 is left. Determine all possible values of n. Now, you see, again, it's just division, right? You did division in primary school. Hopefully, it was covered nicely, right? Where you're dividing by one number by another, and sometimes there are remainders, sometimes there are no remainders. If there are no remainders, it is a factor, and if there's a remainder, then you can actually calculate the remainder by the division process which I've been describing. Okay, so here now we've got an unknown n. So let's just see what's going on here. You got 2025. I'm dividing it by n, and I get a quotient. I don't know what the quotient is. Let's call it q. But the remainder is 16. So we don't know what n is and what q is, right? So they ask you what are the possible values of n. Now, what can we conclude from this? Let's take another example. So I say 40, and I divide it by 7. 7 goes into 40 5 times. Remainder is 5. So what this actually means, when you say remainder is 5, that means 5 was left over. So when you take out 5 from 40, you get 35. And this is 7 times 5. So what you got here is that this number here is 7 times 5 plus 5. 35 plus 5 is 40. Very, very important fact that when you are dividing and getting a quotient, now remember, you stop at 5. I could ask this question here. Why don't you say 7 goes into this, not 5 times, but 4. 4 sevens are 28. 4 sevens are 28. And there's 12 left over. We don't stop here. We could have said this. We could have said that there are 4 sevens in 24, in 40, and there are 12 remainder. But we don't stop there because there is still a 7 inside this. We keep taking out the 7s until you cannot take 7s anymore, which is the same as saying that the remainder is always smaller than 7. This 5 must be smaller than 7. Here, you're not allowed here because 12 is not smaller than 7. You can still continue to take out another 7 from here. So, bearing that in mind, it means that we have two things here. One, 2025 minus 16, as we saw here, 40 minus 5 is a multiple of n. When you take the remainder out, then you know how many n's there are in 2025. And so this is not, this you can calculate. This is 2009. So now you know that 2009 is a multiple of n. Okay, so we're getting there. What are the possible values of n? And the other thing is that we said that the remainder must be smaller than n. And you can't take out any more n's from 16. So n must be larger than 16. So now we are looking for, to say 2009 is a multiple of n, it's the same as saying that n is a factor of 2009. See, the words factor, multiple, divisible, you have to get a good feeling of what these things mean. Right? So it's a multiple of n, or n is a 2009, n is a factor, n is a factor. So you need to write down all the factors of 2009. Now, when you try to work out the factors of 2009, you can try 1, 2, 2 definitely not, 3 definitely not, 2 plus 9 is 11, 4 obviously not, 5 obviously not, and 6, well, this has to be even. Let's try 7. 7, 2009, 7 goes into 20 2 times, 2 sevens 14, carry 6. 7 goes into 68 times, 8 sevens are 56, remainder 4, 7 goes to 49, 7 times, bingo. So 7 is a factor. So it's 7 times 287. Right. Now, as I told you earlier on, 7 is a prime. Let's have a look at this. You can see straight away this is 7 goes into this, 28 and 7. So this is 7 times 41. 287, you can see straight away 7 goes into this. 7 goes into 4, 41. Now these are all prime numbers. 41, right, is a prime number. So now you've got quite a few factors here. 7 squared, this is 7 squared times 41. And as we saw earlier on, it's got 6 factors. 2 plus 1 is 3. So we want to know now what are the factors, because we know n is a factor and it's got 6 factors. So there was 6 possible values for n. Now what are the 6 possible values for n? Let's try 1, 7, 7 squared as we saw earlier on. Right? Just put on 1, 7, 7 squared. And then it's 41 times 1. Right? 41 times 7. And 41 times 7 squared. Right? Those are the 6 factors. Right? You take all the factors of 7 squared. We saw something similar to this earlier on. 41, there's only 41. So you have 41 times 1 and so on. And these give you the 6 factors. I'm not writing them out in full, but all I need to know is which ones of these are bigger than 16. So this is out and that is out, right? Because they are not bigger than 16. But all the other ones you can see are clearly in. So therefore, the possible values for n are, I'm going to write down the answers here. 7 squared, which is 49. 41. 41 times 7, which we saw is 287. And 41 times 49, which gives you the whole number, 2009. So there are 4 possible values for n. See, if I take the largest one, 2009, and I divide this by 2025, 2009 goes into this one time, and you see the remainder is 16. You see? So 2009 is a possibility to actually check to see. You have exactly the same thing with these 4 numbers. The remainder is always 16, and those are the only 4 numbers. Okay, so there are 4 possible values of n. I must apologize for my very poor writing. You know, that is why you have to rely quite heavily on my spoken word, because like this one here, it doesn't look like anything familiar, and it's supposed to be a multiple. I really should write down M-U-L-T, but since I'm writing fast, it is quite distorted. So I must apologize for that. So you have to rely quite heavily on the spoken word. Okay, so that takes care of that problem. And the next problem, go to question 8. P and Q are natural numbers, and P over Q is 7.25. Now, 0.25, as you saw earlier on, is a quarter. So this is 7 and a quarter. If you write 7 and a quarter as a decimal, you will get this, because 1 over 4 is 0.25. Now, this one here is not as a decimal, but it's written as a fraction. And you can actually write this as 7 times 4 plus 1, 28, plus 1 is 20, I'm sorry, 4. So 29 over 4, you see? So the question is 29 over 4. There are 7 4s in 29. This is 7, and the remainder is 1. So this part here is a remainder. I don't think many people are aware of that. Then when you write it as a fraction, like for instance, if I write 29 and 14 over 17, what it means is that this 14 is a remainder. If you write this thing out in full, if you multiply these two, with my fast calculation, I see it's 507 over 17. What this means is that how many 17s are there in 5007? There are 29 of them. And the remainder is 14. So this is the remainder. Okay, so I'm just analyzing what do you mean by what you call a mixed fraction. 7¼ it's 7 times 4 plus 1. You can write it like this, right? Or you can write it as a mixed fraction, or you can write it as a proper fraction. But all fractions can be written like this. If you don't worry about the integer, all fractions can be written as an integer m over n. All fractions. The fractions are also called rational numbers, same thing. Fractions. And they use this big word here, rational numbers. So by rational number, you mean a number of the form m over n, where m is it's an integer. It could be a negative number, right? But most of the time you write it as a positive integer over positive integer, and you put the sign in front. You can put a minus sign in front. That'll make it negative, right? Because minus 29 over 4 is the same as minus 29 over 4. It's a negative of 29 over 4. So all fractions can be written like this with a plus or minus in front. Okay. Okay, that's just a digression. I didn't even go on to see what's going on here. Now, if P is divided by 2Q, the remainder is 10. So if P is divided by 2Q, like that, the remainder is 10. So you got 10 over something. Because we just saw that the remainder is going to be like this. Right? So the question is, what is the remainder when P is divided by Q? So how do we do that now? Now here, one very important, extremely important fact about fractions is that a fraction can be written in many ways. 1 over 4 is the same as 2 over 8, the same as 3 over 12. You can multiply the numerator and denominator by any number you feel like. Right? 100 over 400, 100 times 1, 400, 400 times 4, and so on. So there are any number of ways you can write a single fraction. So when you are writing this as 1 over 4, this need not be the unique way. You could have written 7 and 2 over 8, or 7 and, if you're multiplying by 3, 3 over 12. So you can write this fraction as quite a few ways of writing it. See? So let's see which one it is. They say when it's divided by 2Q, the remainder is 10. So if you look at this one here now, if you take 29 over 4, and you say, is P equal to 29? And Q equal to 4, because we got P over Q. Now, when you try this, when you divide P by 2Q, you get 29 divided by 8. And the remainder is 5. 8 goes into 29, 3 times the remainder is 5, not 10. See? So P is not equal to 29 and 4, P and Q. They're not equal to that. Let's try the next one. Let's try 7 and 2/8. Now that is 56 plus 2 is 58 over 8. Now here 2q is 16. So you got p. If suppose p is this 58 and is divided by 2q. Q is 8. So 2q is 16. Now 16 goes into 58. 16 times 3 is 48. And the remainder is 10. Ah, yes. So this is good. So this is where we are. When you try the next one, you see that the remainder is 10. All right, so this is the thing that works. So which means now that P is 58. It worked here. And 2Q is 16. We actually had Q is equal to 8. So this is where we had 7 and 2/8. This one here is 58 over 8, you see? 56, 58 over 8. So this is the way that P and Q are. So what is the remainder when P is divided by Q? So you divide P 58 by 8 now. That's Q, not 2Q anymore. And when you divide 58 by 8, it goes into 7 times, and the remainder is 2. The question is, what is the remainder? So that's the answer to this question. And this is called equivalent fractions. So you can fall into the trap by saying that 7.25 is 7 1/4. Stop. Right? It's quite right. But we have the habit of writing this thing in the simplest form, 1 over 4, without taking into consideration that there are many, many ways in which you can write a quarter. So if you write it as 2 over 8, then it's still quite correct to write it out like this, except that the fraction is not written in the simplest form. Simplest form means there are no common factors between the numerator and the denominator. If you've got a common factor in the numerator and the denominator, right, you don't write it like this. You say 7 goes into the numerator and 7 goes into the denominator. So you cancel the 7s and you say 14 over 21 is 2 over 3. That's the simplest form because you can't simplify that any further. You take out the so-called highest common factor, right? Okay, so that's the answer to this problem. Again, you see, it's just ordinary fractions, and yet, the questions can be so searching, where you have to analyze exactly what you are doing with all these things when you're working with fractions and division and so on. All right. So that it's a very beautiful learning experience going through all this, because you think you know all about these fractions, but then when you start looking at it carefully, you see it's not really, you don't really know so much. Now let's go to the next one, question 9. Question 9 says, you got 3 prime numbers. So x, y, and z are prime numbers. Right? They could be coming from 2 or 3 or 5 or 7 and so on. Okay, so they are prime numbers. And you've got xy plus xz is 80. Now, I wouldn't leave it like this because this is x is a common factor. You can take it out. X into y plus z is 80. Right? Okay, so that's the first fact. And here again, y is a common factor. Y comes out into x plus z is 425. Okay, and they say calculate 5x plus 2y plus z. All right, so having written it down like this, and this is very helpful because what we are saying is that 80, one of its factors is x, and another factor is y plus z. The same thing with 425. One of the factors is y, and The other factor is x plus z. But remember, x is a prime. I'll write down x as a prime number, or sometimes I'll say x is a prime. So you have to see what are the prime factors of 80. 80, when you factorize it like the way we said earlier on, I'm not going to go into detail, it is 16 times 5. And 16 is 2 to the power of 4. And 2 and 5 are prime numbers. So if x is a prime factor of 80, these are the only two prime factors. X is 2 or 5. The only prime factors of 80 are 2 and 5. All the others are not prime, right? Because then you'll have 4 times 5 and so on, which is not a prime. Okay, so there are only two possible values for x. And the same kind of a thing here now, y is a factor. Y is a prime number also of 425. And again, you have to factorize this. Okay, 5 goes into this. 5 goes into this 85 times. 5 goes into 42 8 times, remainder 2 and 25. 5 still goes into this, so this is 5 times 5 times 17. So this is 5 squared times 17. So now that tells you that y is a prime factor of 425, and 425 has got only two prime factors, 5 or 17. All right, so you got two possibilities for x and two possibilities for y. And at this stage, I'd like to write down the pairs, all the possible pairs of x and y. X could be 2 and y 5. X could be 2 and y is 17. Or you could have x is 5 and y is 5. Or you could have x is 5 and y is 17. So you could 2, 5, 2, 17, 5, 5, 5, 17. And that gives you all the possible pairs of x and y, and you can see x and y are prime numbers. So one of these pairs on one or more actually works. All right. So how do you do that now? We haven't used anything about z. Z is also a prime number. All right, so let's calculate z in each case. So z is equal to, in this case, if x is 2 and y is 5, all right, now I need to make a little calculation here. If x is 2 and y is 5, let me make this calculation in the corner here. X is 2 and y is 5. 5 plus z is 80. So I can substitute for x and y in this, and you get that. And therefore, 5 plus z is 80 divided by 2 is 40. And here you get z is equal to 40 minus 5 is 35. And this is not allowed because z is a prime number, you see. All these are prime numbers. So you can eliminate that one. So like that, you can eliminate, let's say, try 2 and 17. I'm going to make the calculation in the same place. 2 and 17. What do you get? Now, x is 2, y is 17. 17 plus z is 80. So 17 plus z is 40. And z is 23. Ah, this is fine. Z is 23, you're allowed. So, therefore, z is equal to 23. And therefore, x, y, z will be 2, 17, and 23. That's a possibility. And I think we can eliminate this because they say these are three prime numbers. Now here you got x and y are the same. So that doesn't make three. In the end, you'll only get two prime numbers. So you can knock that out. And I think if you try this one here, this also doesn't work. I'm not going to go through that. And this is the only solution. You can see why this is not a solution. You can do it. And then you can calculate 5x plus 2y plus z. Right. You know what x is. You know what y is. You know what z is. So we'll try to do it quickly, mentally. Might get the wrong answer. 10 plus 34 is 44 plus, I think you get 67. You can check that. I think it's, when you work x, y, and z and you substitute it, you get 67. All right, so that seems to be the answer to this question 9. And then let's get on to the next question. Oh, this is a huge story here. Okay, I've got 7 minutes to do this. So let me read through this thing here. You got 100 empty glasses are arranged in a 10 by 10 array. Okay, I'm going to just go down here a little bit. Okay, yeah, I've got 10 by this is a 10 by 10 array. Don't worry about the colors and all the anything else. Just imagine I got a blank 10 by 10 grid like this. A chessboard, a funny looking chessboard with 100 squares in it, 10 by 10. And they say here that 100. Now we pick any A of these rows. So I've got 10 by 10. I'm not filling in these squares here. I pick any A of these rows. You can see what I've done here is I've got A here. So these are A rows. A could be one row or 2 rows or 3 rows or anything up to 10 rows, but A is not given. Pick any of these A rows and pour blue liquid into those rows. So I've got blue liquid all over here. I've got B here. So all these are all B's. You got blue liquids here, but there's no. Now why is the B liquid? I see. All right. This requires a little bit of juggling to understand this. Anyway, these rows here, you got blue liquid put into them. Let me just color it like this. And then I could have used blue. And then I also got yellow. Right. So blue liquid is put in so that they are half full. All right. So these A rows, the glasses here are half full. The blue, sorry, I've changed the color a bit too soon. So they are half full. So you got all these, I've got half full glasses. The remaining rows are filled with halfway through yellow liquid. So maybe I should use the colors now. Sorry. Okay, these are glasses. Oh no, we want black. So you got these glasses at the bottom, and then you got it filled with blue liquid at the bottom. And they say, so right through you got these glasses look like that. And this and you say the remaining uh, rows are filled halfway with the yellow liquid. So these rows, the remaining rows, are filled with yellow liquid. So I'm going to fill them with yellow liquid now. And right, so you got all half yellows here and half blues here, right? Now afterwards we pick B of the columns. So I've chosen B. It doesn't really matter which columns they are. I can put all those, rearrange them so that the B's are all in the first few columns. The remaining one, there are 10 columns altogether, so there are 10 minus B here. Right? So now what you do is you take the B of the columns and fill them up with blue liquid. So what happens here is that I'm going to take B of these columns and like here now, I'm going to put B of these columns with blue liquid. Sorry. So here I've got B plus Y, you see. Here I had Y, but I didn't put anything. The remaining columns are filled with yellow liquid. So these remaining columns have got yellow liquid. So I got Y plus Y. So like that now, I've got B plus Y. This is a mixture of B and Y. This has got Y and Y twice. And here you got B and B twice. So that remains as blue. And then here I've got Y and B. All right. So half of them is blue, half of them is yellow, and sometimes you got both halves are blue and both halves are yellow. So that's what I'm capturing that information into this diagram here. Right. Now what happens is when blue and yellow when they are mixed, you get green. So I can put this part here, I can put green here. Y plus B is green here. And Y, that's why you're all yellows here and all blues here. Right. So that is the picture there at the bottom. So this is, all these glasses are now full. Originally they were half full, now they're all full. And there are questions raised about them. Let's see what the questions are. Right. Determine all possible combinations of values A and B so that exactly half of the glasses contain green liquid and contain green liquid at the end. All right. Now we want exactly half to contain green liquid. Now you got green liquids here. So you want to know combinations of A and B so that exactly half of the liquids contain green liquid at the end. Now, how many green liquids are here? This is a rectangle, and you got B columns and 10 minus ABs, so you got green. Maybe I better go back to my black writing. The greens are the mixture of B and Y, you see? So it's the number of glasses here will be B times 10 minus A, right? Because it's a rectangle and the number of glasses here are B times 10 minus A. And here you got plus, you got green here as well, but here the rectangle has got breadth A and length B, 10 minus B. And these two together gives you exactly half. In other words, it's 50. Because there are 100 glasses altogether, and you want these put together to be 50. So what do you get? You get 10B minus 10A plus 10A. No, I'm sorry, minus AB. 10 times B and then you got B times A, AB, and here you got 10A minus AB, and that is equal to 50. Right, so you actually have, you got two ABs here, so let me put them all together. You get 10B minus 2AB plus 10A, then I'm grouping the ABs together, and minus 50 equals 0, right? And you can actually see that you can factorize this. This is, okay, the 2 is cancelled, so you have 5B minus AB plus 5A minus 25 equals 0. And the B's can come out as a common factor here, B into 5 minus A. And yeah, you got 5 into A minus 5. I can make this minus 5 into 5 minus A. I want to make 5 minus A in both places. So minus 5 times 5 is minus 25. I'll put that in front. And minus 5 times minus A is plus. So you got 5 minus A is a common factor. B minus 5. So you got a product of two numbers is 0. Right. So now they say determine all the combination values of A and B so that exactly half of the glasses contain green liquids at the end. So what we have here is that A is equal to, if you got the product of two numbers is 0, that's a very important thing. When two numbers with the product is 0, one of them must be 0. Very important fact. See? If two numbers, if the product is 0, one of them has to be 0. So in this question A now, you got this product is 0, so A equals 5 or B equals 5. So it means that either the number of rows is 5, and that you can see, if you had exactly 5, A is 5, you're gonna get half the numbers are green here. You'll have that square is the same as this one. Anyway, A equals 5, and if A equals 5, A, B, then nothing is said about B. This is OR. So you can have A equals 5 and B could be 0. That means we didn't choose any columns at all. Or B could be 1, or B could be 2, all the way up to B going up to 10. And if B is 5, then you got B is 5, you got 5 there, and A could be 0. Landing up at 10, 5. Okay, so the 10 plus 10 is 20. Actually, you get 19 here because 5, 5 occurs twice. So there are 19 possible combinations for this, 19 answers. Because you've got A equals 5 or B equals 5. See, if A equals 5, this becomes 0. Nothing is said about B. If A is 5, this is 0 anyway, regardless of what B is. That's the important thing. Because one of them is 0. The other one could be anything. It's still, the product is still 0. Okay, now the next question, is it possible that 1/4 of the glasses contain green liquid at the end? In other words, it's you got 25 glasses is green. So there, to answer the question B, sorry, I've exceeded my time here. Sorry about this, but this is the last question. So the question is it possible that we're going to have, you see, when we calculated this thing, we saw that the number of greens, if you recall, number of greens originally was, I think you had something like 10b minus 2ab plus 10a. Yeah, it was like this. Right? And you want to know, then we had 50 here, and we solved it. But the question is it possible that a quarter of them are green? In other words, is it possible that this is equal to 25? The answer is no, because this is even, you see. Right? This number here is even. 10 times something, 2 times something, right? 25 is not even. So it's not possible. All right, so you can see that these questions are quite demanding. That's the last question. Thank you very much for being here till the end. I will be quite happy to answer any questions that you have, something that you want me to repeat. I'll be happy to do it. And those who wish to go away, if they haven't gone already, can leave, and the others can remain behind, and you can ask me questions and listen to the answers that I give to those who ask me questions. Thank you very much for your attention. And I'm now going to go to the full screen to see which hands are raised. Okay, guys, that's been for me, it was an interesting session because it gave you a lot of insight into problems involving natural numbers. I'm sure you learned quite a lot about factors and factorization and prime factorization and fractions, all those kinds of things. And and you thought you knew everything about counting numbers because you finished counting numbers in grade 5 or something like that, or grade 7, where you were introduced to negative integers. And after that, you said goodbye to the counting numbers as though they were very trivial. They are not. Okay, any questions? I don't know whether you've written anything in the chat column. Khotso, is there anything in the chat column that I need to address?
No, Prof. I can't see any question.
Those questions are all administrative, huh?
Yeah, I think so.
You'll take care of that. You will answer each of these people.
No problem, Prof. No problem.
Yeah. So my good friend Khotso, who I failed to welcome from South African Maths Foundation, he is our main helper here. He will answer all your questions and write back to you and tell you what your issue is, especially regarding your tutors and your center managers and so on. Most of the questions will have to be addressed to your tutors. Your tutors have been specially appointed to take care of you. So you must exploit that. And he was right. Get hold of your tutors. And Khotso, if you can, just give them the email addresses and the telephone numbers so that the students can contact their tutors directly. And they need to give their questions to the tutors, and the tutors should be able to answer it. All right. So are there any questions now? You didn't put anything in the chat column. Do you have any questions which you want to ask? You can raise your hand. And thank you very much for your good behavior today. Nobody wrote on my screen. Nobody had the telephone, the audio on. So there was no need for me to listen to cats meowing and dogs barking and children crying. All right. Or your grandfather snoring. So it was a very quiet and eventful evening. All right, Lebo, you want to know, can we have notes? Lebo, we don't have any notes. Khotso, I don't know whether my notes are recorded, but sending the notes would be quite a problem because there are many pages. You answer that. You ask, can we have notes?
I'm not too sure, Prof, about the notes.
Yeah. Yeah, but you have access to the pages as we go along. Oh, okay. We could have notes if we use whiteboards, but I didn't use whiteboards. I used just a screen in front of me. So the answer to your question is you have to look at the recording. Unfortunately, you have to do that. The recording is very big, and if you don't have enough space, data space on your telephone, then you have a problem. Also, can you address that one?
Okay, regarding kangaroo, yes, you will still take place for Olympiad even if you fail kangaroo. Kangaroo was just to strengthen your problem solving ability, your critical thinking. It doesn't count anything. We just wanted to build to train you and to prepare you for the upcoming Olympiad, which is going to take place next year. Also for uh the Stellenbosch camp, which you guys were going there for December. We are preparing you for those challenging questions so that you can have an idea which questions, how they're asking questions, how to approach those questions, and how to uh tackle those problems. Yeah, it doesn't really count. You won't be penalized or be affected if you fail that test. We are just testing your ability only.
Yeah, but what is counted are your assignments. So you must try to submit as many assignments as you can and try to get maximum marks, because from this lot, some of the students will be chosen for the Stellenbosch camp. It all depends on your attendance and your assignment.